Okay, Lamai. So in the last week, we learned basically about what is energy and types of energy and how to apply. It was like a very basic knowledge. So let's try to figure out and how was it and just kind of like a quick recap. After that quick recap, we are going to start regular lesson. To start the regular lesson, we have to have like a quick recap. That's going to be really much better because in that one we are going to deal something called what? The law of conservation of energy. That's really uh, heart of this lesson actually. So somehow let's have a quick recap of the last week lesson. In the last week we learned something like the work. I told you it is with no specific definition because it is the product of force and displacement. Product of force and displacement, work equals to force into displacement. Today, actually, one of my students just asked me a question. So, how to solve this question? It is really horrible, and can you just give me a tip to solve it? That's what he asked. Then, actually, it was a tricky one. I just applied that question to trick you. Absolutely. So, I could see that he got really tricked by the question. It's about pushing a wall, applying a really high force, but what is the work done against the wall? So the force, the amount of force you apply does not matter, is irrelevant as long as you are not moving the wall to somewhere. What wall එක move වෙන්නේ නැත්නම් කිසිම work එකක් කරලා නැහැ. ඒතර work done is going to be zero. අන් ඒ වගේ පොඩි tricky දේවල් ටිකක් තිබුණා. You forgot the factor. You have a force, yes, that's fine. But the displacement is zero. There will be no work. Work count will be zero because imagine like 1 million. 1 million into zero is still zero. Regardless. Okay. Regardless what is the unit, it doesn't matter. You multiply by a certain value of zero. Your final result is zero. අන්න ඒ කතාව ඔළුවේ තියෙනවා. හරි නේද? මම හිතනවා ඒක තේරෙන්නේ නැති කියලා. මට විනාඩියක් දෙන්න ළමයි. Okay. So you have to always consider about the displacement as well. Now, and I told you something about the types of energy. Normally, energy is the ability to do work. So if you can just drag something along a long path, so you apply certain force against something, but it's you have to do some work by applying a force again along a certain direction. That's the reality. In that case, sometimes you may do a work against what? Gravity. Gravity means you lift something by putting some hard amount of force against certain force, or pulling a spring, stretching a rubber, or kind of like dragging something against friction. So the force can be done against anything. So the ability to work is known as energy. So energy, basically, there are two types. What are the basic two types? Basically, stored energy due to change of position, we used to call it as, what do we call? Change of position. It is called potential energy. And the energy stored in due to the motion of an object is called kinetic energy. Yeah. So in the terms of potential energy, there are many ways of expressing the potential energy. So electrostatic potential energy, gravitational potential energy, and kind of like elastic potential energy. We talked about two ways of expressing those. One is gravitational potential energy, ground level. So if there is a mass of m here, you can lift this mass up to some certain height above the ground. So that one is simple H. Your weight is there, W equals to mg. Again, W equals to mg. Mg, your work is done against this weight. Weight means the gravity, against gravity. So the work done is force multiplied by the distance. So here it is like mg by height of h. That is known as EP, potential energy. I hope you understood that. Yes or no?
Yes, sir.
Okay, very good. It is called mgh. Right. The next up is other type of potential energy. I told you the real gravitational potential energy we are not learning in this lesson. We have to do it in the next future lesson. It's called in the gravitational field. So, and the electrostatic potential energy we have to learn in electrostatics. So for the mechanics, we have another type of potential energy, that is the stored energy in springs or stretched springs. So in that case, we learned something like this. At the beginning, extension is 0, so the force is also 0. So at here, the extension is some time of delta x. Now there is a force of F. So W equals to Fx. That is what we know. The energy content is E, W. So the force is 0 plus F over 2 times X. Because why? At the beginning, the force count was 0 because no extension. At the extension of X, the force is equals to F. So your force is F now. So the potential energy is going to be 0 plus kx over 2 times x. So the potential energy count is going to be kx to the power 2, half kx to the power 2. And I told you this lesson will come strongly in the other case of simple harmonic motion. We have to learn about spring systems one by one in detail. So for this lesson, we only have to worry about potential energy is equal to half k x to the power 2, where x is the what? Spring constant. Okay? Hari neda? Say yes.
Yes, sir.
Okay. Very good girl. කොහොමද කට්ටිය තාම පරක්කු මොකද? And I told you another important thing. So sometimes we may have to do work against something called friction because of roughness of the medium. And I explained you using this Rigiform board. Your test, I will do the test as soon as you guys tell that me that you are ready. So if you are ready, we can have it on this week. If you are not ready, we can have it in whenever you want. ඔයාලට කැමති දවසක් කියන්න අවුරුදු කාලේ තියෙනවා නිවාඩු දවස් ඇති තරම්. We have many vacation days, so we can have it on any of these days. So you have to let me know when to want. So if you are ready, we can have the test. ඔයාලා කැමති ඕනම එකකින් අපි ටෙස්ට් එකක් තියමු. It is up to you. May first week වෙද්දි ගොඩක් කට්ටියගේ ටෙස්ට් කියලා ඉවර වෙලා තියෙයිනේ. බලන්න ඔයාලා මට දිනයක් කියන්න, හැමෝම මට secretly message කරන්න telling a date. So I will go along with the majority. If the majority of the people like certain day, that's it. Right? So work done against friction. So it's just something moving, but the force of friction is there. The object moves somewhere like a distance of d along the floor with the frictional coefficient of mu and the mass of m. So your work done is going to be W equals to F into D. Since the force is the friction, it is going to be mu mg. So the force we can apply mu mg times distance of D. So the work done is mu mgd. මේ වගේ කිහිපයක් අපි last week එකේ කරගත්තා. මම හිතනවා මතක ඇති කියලා. I hope that you guys remember this. එමනේ? Is that or isn't that? Right. So, and open another subtopic before going for the law of conservation of energy. We have to know types of energy and how to apply it. So can you remember that I told you how to generate the momentum of a moving air column or water column? Can you remember? So it is like this. I just gave you something about moving water column, momentum of a moving water column in a tube. Moving water column in a tube. Density of rho and the having cross-sectional area of A, and it will travel L with the velocity of V, T equals to 0 and T equals to T. So can you remember the amount of momentum we generate? Huh? Can you? මතකද? Yes or no? Hello? Yeah, you can remember. Very good. Operation is our Right. Okay, have a good look at. So the momentum is m into v. P equals to m into v. So the momentum, we had like certain equation, what? Rho a rho v to the power 2. So we are just going to get something similar to that in the case of energy. So write it, kinetic energy of a, write it, kinetic energy of a moving, kinetic energy of a moving fluid flow, moving fluid flow, moving fluid flow, moving fluid flow, moving fluid flow across a moving fluid flow across a kinetic energy of a moving fluid flow across a moving fluid flow across a certain area perpendicular to it. Across a certain area perpendicular to it. Right. Example එකක් ගමු. Let's take an example. It's like a fan. So we have to consider about the amount of area swept by the fan here. The area swept by the fan here. It is A, right? So the amount of what? Amount of fluid flow is going to be moving across it, like in this manner, isn't that? Emane? With the velocity of v and moving with the density of rho, and the energy is going to be ek, kinetic energy. Aned? I hope you understand. Okay. Now do it like this way. So you can write an example here. So you may write turbines and windmills turbines and windmills use this type of energy to convert it in to convert it into useful manner. The kinetic energy of water, we have to convert it into electricity. So sometimes we have to convert it into some other form of kinetic energy to grinding grains and other things. So we have to convert it into some other manner. The amount of energy content can be calculated in the following way. So how do you find it? The only way to find it is half m v to the power 2. Half m v to the power 2. Right. Have a good look at how to find out the mass of this volume. Density is equals to mass over volume. Mass is equals to density into volume. Density into volume. This is the equation number 1. So equation number 2. As we know that density is equals to rho, we can write it like rho v. Equation number 2 is still. So what is the volume? Since this one is like a cylinder, we can get the volume of a cylinder in this manner. Area into length here. Area into length given in here. Right. This is volume V, capital V. Equation number 3. So I can substitute the equation number 3 into equation number 2 here. And finally, I will be able to get the equation for mass. It's going to be rho what? A and rho AL. And one thing is to be concerned here. Number 4. What is this length? What is this length? So we know that the time is equal to 0. When we consider time equals to 1 second, the length traveled and the velocity is v. We know that the velocity is equal to length over time. So for unit second, time of 1 second, we know that length is equals to velocity. Length is exactly equals to velocity here. So my equation will be, this is equation number 5. Now I'm going to include 5 into equation number 4. So my answer will be m equals to rho a v. Equation number 6. Now I am going to substitute this equation number 6 into my first equation. Right. Then I'm finally getting the equation for Ek equals to half rho a rho v to the power 3. Half a rho v to the power 3. This is it. Very simple. හරි නේද? දෙයා ගන්න ළමයි. හරිද?
Not yet, sir.
What? Ramai, this exact thing was there in the can't remember the year actually. Kind of 2000 or 2001 or 2. I think 2000. Year 2000 or 2002. I can't remember. Year 2000. I think. In the paper, this exact concept had come. So in the term test even, you have to derive these things and so. So everything is really important. I told you in the last week in likes of in O level, we just get the equation and apply. Most of the time, we don't want to know the pedigree of that. It is something like your school age friends. You are not going to see his family background and anything. You just keep in touch with them. But it is going to be a next step when you are just going to be with like professional related friends. When it is come to think of the professional related, you are just considering about his all the things like how his family and everything, because you are going to deal with some kind of money related things. If he is coming from a very bad family, he might do something smuggling and stuff. So everybody get caught. So you have to know his pedigree. And in terms of marriage, you are just finding his grandfather's stuff even. So here, A level is something like a permanent bond. So you may have to know all the information about the pedigree by just proving it. If you know how to prove it, that means you know most of the very important things in that. Okay, Arine? Right? I hope you guys understand this. Right. The very basic types of energy formation we have done, how the energy works, most of the things we have done now. Now the next up thing is we have to deal with very important scenario. What? That is called the law of conservation of energy. Energy types of for mechanics is normally done now. It is about the law of conservation of energy, right? First of all, we have to know what is it, right? As long as you know what is law of conservation of energy, as long as you concern of it, what is the law of conservation of energy? Do you know or not? Now, just tell me. I told you guys to just search for what is law of conservation of energy. I don't know how many of you did. Energy is the same. Okay, very good. There is a thing called the law of conservation of energy. In the first time when I was in the A level even, I got really shocked after hearing that. Potential energy equals to kinetic. No. It is something roughly yes. Roughly yes. A person he said energy is not created or destroyed. Yes, that's it. Very good. So in the first time, I got really shocked when I was in the A level. I really thought like, how the heck? Because I thought like we can produce energy. But then only I realized that we are not actually producing, we just convert one form to the another form. Energy transferring without losing energy from one form to no. Actually, it transformed to many other forms. It doesn't matter. But the initial energy count will be the same energy count at the end, even though energy is being dissipated. Dissipated means converted to the other forms rather than what we want. Imagine like I turned on a bulb, right? My first priority for the bulb to produce is light energy in the visible spectrum. Imagine like 100-watt bulb only gives off, imagine like only 5 watt of visible light. So the things I want is this much, but it will produce more than like 80% of energy in terms of heat. Is that the thing I want from a bulb? Heat? Do I need heat? In some cases, yes. In some cases, yes. With those incubators and other things, we need heat energy from bulbs. And also the chicken farms like of this, like boiler pumps. So we use like bulbs to keep the heat. So and sometimes we need, but in the real life, we need what is it? Just light. So and also it may form like 10 to 15% of what energy of other spectrum. We can't see like other spectrum, and somewhere like 5% of sound energy, even if we can hear clearly. So these things really unwanted. So the wanted thing is known as useful energy output. What? Useful energy output. So there is a thing called efficiency. What is the meaning of efficiency? The percentage of useful energy out of from the input. So that's what you were mentioning. So there are other forms of conversion, but still, if you count all of these together, as an example, as I wrote, 100 is the thing I get. My useful output is 5, but 80% is just wasted. 10% is for other form of energy. 5% for sound. In a bulb, do we get sound? Oh, පොඩි sound එකක් හැදෙනවා අපිට ඇහෙන්නේ නැති වුණාට සමහරවල්. So how about all of these things together? It is again 100. හරි නේද? Energy dissipation also we have to count. Finally, the initial amount given should be equals to final amount, right? So the law of conservation of energy stands for what? So the energy cannot be created or destroyed during a process. It converts from one form to another. කිසිම දවසක මවන්නවත් බෑ විනාශ කරන්නවත් බෑ. Energy lost. We say like energy lost. That means it is destroyed. No. It has converted to something that we never want, unwanted. When you're turning on a vehicle, the vehicle engine may produce sound. Kilometer 10ක් ඈත ගෙට්ටත් ඇහෙනවා අරු බයික් එක start කරා. Is that what we want? Yes, sometimes that is the thing we want, rather than riding the bike. Why? We put like a beat silencer and stuff, and they make sound more audible. එහෙම කරනවානේ. එහෙමත් කරනවා. හරි. Actual thing is, vroom vroom vroom. That is the sound we want. But actually, the real world, we only need the 100% of fuel efficiency for riding. But it is not going to happen. But somehow, the energy lost is not the destruction. It is the conversion of that energy to something we never want. Still doesn't matter, fine, why? The energy is not destroyed, it has converted to other forms. This is actually the first law of thermodynamics. You will get to know what is thermodynamics in the heat lesson. Even 24 students don't know about that. එහෙම නේද සරීනා? සරීනා ඉන්නවද?
Yes, sir.
අපි තවම දන්නේ නැහැ නේද? Thermodynamics.
No, sir.
In 3 weeks time you will get to know. හරි. අද තව අලුත් ළමෙක් ඇවිල්ලා ඉන්නවද? Hello?
Yeah, sir.
Mainly. There is a girl called Vanara. She is coming from actually a weird group to this one. That is, she's from 1-year program to this one. She's in the 1-year program and she just wants to join to this class even. Really good girl. Do really hard work. Even I just asked her to write like 24 heat lessons, all the recording notes and stuff. She wrote everything and sent me. අන්න එහෙම වැඩ කරන්න ඕනේ. දවස් දෙකයි මම ඉන්නේ දවස් දෙකයි තුලද කොහොම ටික ලියලා ගණන් ටිකක් හදලා ඉවරලා මට එවුවා. එහෙම නේද?
Yeah, sir.
And I also happen to know one thing. She is also from Opesanith school. Opesanith යාගේ යාළුවෙක්. Opesanith ඉන්නවද?
Yes, sir.
යාළුවෙක් නේද?
Yeah.
කොහමද? දෙන්නම හොඳට වැඩ කරනවනේ ස්කූල් එකේ.
Not bad, sir.
Imagine like me producing 2 island rankers in the same school. කොහමද එහෙම වුණාම? So like island first and second goes for these two. අනිත් කට්ටිය කියනවනේ එහෙම කරන්න බෑ සර් අපිත් ඉන්නවා කියලා. ඔයාලත් දෙන්න ඕනේ හොඳ ගේම් එකක්. හරිද? ඒතර හැමෝම මට ඕනේ island rank එකකටම try කරන්න. එතකොට කොහොම හරි අනිවාර්යයෙන්ම මෙඩිසින් යනවා. සරිනා කියනවා ඒක තමයිලු නෑ. ඔයා ඉතින් නෑ මේකට. ඔයා ලියන්නේ 24 එකේනේ. ඔයා ඉන්නේ 24 එකේ. ඔයා 24 එකෙන් මට rank එකක් දාලා දෙන්න. හරිද? 25 කෙල්ල ලියන්නේ 24 එකේ. ඉතින් ඒක නිසා ඔයා 24 එකෙන් දාලා දෙන්න. කවුද? අනිත් දෙන්න 25 එකෙන් දාන්න. මට වෙන විදිහට නම් කෙල්ලත් දැන් 25 එකේම ලියන සීන් එකක්ද මන්ද තියෙන්නේ. එහෙමද සරිනා? 24 ලියනවද 5ද ලියන්නේ? ආ? සරිනා 24 ලියනවා. එහෙනම් ඉතින් ඔයාලා ස්කූල් එකෙන් අයින් වෙනවා තව මාස කිහිපෙයි. You have to
Still thinking of it, sir.
මොකද්ද? මොකද කිව්වේ?
බලන්න. තාම හිතනවා.
මොකක් මට ඇහුන්නේ නැහැ. නිකන් එන ඕල්ඩ් වොයිස් එකකින් ඇහුනේ. හරියලා මේක මන්ද හිටියේ. සරිනාගේ අම්මද මන්ද හිටියේ. අම්මෝ. හරි. තාම හිතනවා. ඔයා හිතේ තියෙද්දි ටයිම් එක ගිහලා තියෙන්නේ. මම දැක්කලු යාළුවෝ වෙන සෙට් එකක් හම්බෙලා දැන් යාළුවෝ ටික දාලා යන්න බෑ වගේ හිතෙනවා නම් කෙල්ල ලියයි 25 එක. කොහොම තමයි වෙන්නේ. එතකොට ඉතින් අර දෙන්නටත් වෙන තරගයක් දෙන්න වෙනවා. මේ මිනිස්සුත් ඕකටම ෆයිට් කරනවනේ. හරි. Useful energy. Right. Useful energy output. Right. Write the law of conservation of energy. The energy content is constant during a physical process since the energy cannot created or destroyed energy content is constant during a physical process since energy cannot be created or destroyed. It can only be converted from one form to another. හරි එක જાතියකින් නම් තව જાතියකට කන්වර්ට් කරන එක විතරමයි කරන්න පුළුවන්. Let's get a real example. Round and having a mass of m, u equals 0 and there is a height. So here we only have potential energy that of mgh, and it will gain some velocity of v, and it will gain some kind of kinetic energy half mv square, and here the ek constant is 0, kinetic energy is 0. Here the potential energy content is 0. So you finally can write like the energy initial should be equals to energy final, considering during what? No energy lost. කිසිම energy එකක් loss වෙන්නේ නැහැ කියලා ගත්තොත් you can take it like mgh is equals to half m v to the power 2. ඔක කපලා කොටලා දාන්න එපා. කොහොමම තියෙනවා. පස්සේ ගණන් හදලා විතරක් කපලා දාමු. Because we can cancel off m to m and get final result. So you can get it like gh is equals to half v square. So v is equals to 2gh over root 2. මේ වගේ කතන්දර ගොඩක් කරන්න පුළුවන්. But you stop from here. Let's apply these knowledge in calculations only. හා නේද? හා කියන්න ළමයි ඔය කියන්න. Lamai, after this lesson done, I will speed myself up like if my speed is like x now, I will speed it up to 1.2x. Right? බය වෙන්න දෙයක් නැහැ මොකද basic knowledge එක හොඳට හදන්න ඕන නිසායි මම ටිකක් slow කරේ. Now the very basic is until to law of conservation of energy. ඊට පස්සේ basic කියලා ලොකුට දෙයක් නැහැ. හදාගෙන යන්න තියෙන්නේ. But I will speed myself up to like 1.2x. So finish the mechanics, then a little bit speed up. So I told you, even in my curve, I will be speeding up. I told you, this is like a climbing a mountain. So I will speed gradually up. In the first day, I said, can you remember? But in some others, they may just do it like this way. Some others start like this and go like this. So very weird. So my case, I speed up gradually. ඒක ඔයාලට දැනෙන්නවත් නැති විදිහට ස්පීඩ් කරනවා. So increase your writing speed and your thinking speed, the work capacity a bit. චුටු චුටු වැඩි කරගමු ටික ටික. එකපාරට ඕනේ නැහැ. So then you will be able to catch everything up. After this lesson is done, we have to go for very important lessons that is called circular motion and rotational motion. After that, we have a thing called hydrostatic and hydrodynamic. Then the mechanics is completely over. ඉතින් ඒ දේවල් ටික හරියට ඉවර කරගන්න නම් හරියට මැච් එක ගහන්න ඕනේ. The law of conservation energy is a very important. It will determine your physics. So pay more attention to there. Right. So there will be a certain equation that is not in our syllabus, but will be really important to use in many areas. So mostly use that for MCQ purpose. essay වලට වැඩි පාවිච්චි කරන්න එපා අපේ syllabus එකේ නැති නිසා. But I will tell you something it is going to be really important in using in MCQs. Let me explain you that. Having a mass of m which is moving at velocity of v and it has a momentum of p. So the equation is going to be, and this one has a kinetic energy as well with the momentum because of mass and velocity. So the kinetic energy is also controlled by mass and velocity, and the momentum is also controlled by mass and velocity. So for kinetic energy, I can write the equation like half m v to the power 2, right? So we know that thing P equals to mv. Okay, now if I multiply this by again by m up and down, if I do something to up, we have to do the same thing to the down as well. That's not very out. So now the equation becomes ek equals to half m square v square over m. I කපලා දාන්න එපා දාපු එකේ තේරුම ගන්න වෙනවා. So we can write it like what? Half mv square divided by m. Right. What is this m? mv square. What is this MV square stands for? Yeah. What is this MV square stands for? Tell me. Hello. Very good, Opesani. Others? Sarina, yes. It is going to be, since P equals to MV, you can replace this equation by EK equals to P square over 2M. Mostly this equation is not in our syllabus, but we can use this in finding answers for MCQs very usefully. ඕක එක නිසා essay වලට use කරන්න එපා. මේ syllabus එකේ නැහැ. ඒක ගොඩක් වෙලාවට මේකෙන් දෙනවා nuclear physics වලට මේ theory එක දීලා equation එක දීලා ගණන් හදන්න දෙනවා. දැන් අලුත් trend එක ඒකයි. ඒක නිසා මේවම දීලා තිබුණොත් හොඳයි කියලා හිතෙනවා. Because why? In the new trend, most of the time the new papers are come up with something, certain equation you have never seen in your life. They give the equation, briefly explain, asking you to do. මම ඒවලට ප්‍රැක්ටිස් එක පටන් ගන්නවා තව ටික දවසක් කියලා. ඔයාලට එකපාරට පටන් ගන්න නැත්නම් මොකද මම දන්නවනේ එළියේ ක්ලාස් වල යන විදිය. Because I started to teach in one of a leading girls school in Nigambo. Hi, ඉතින් අපි දැන් අපි මෙතන ඉන්න ළමයින්ට හදලා තියෙන වෙක්ටර්ස් වලින් මම පටන් ගත්තේ. මේක ඉන්න ළමයි අස් වහගෙන හදන වෙක්ටර්ස් මේ ළමයින්ට හදන්න බෑ. They can't. The reason is they are going for the very famous classes in Nigambo region. But unfortunately, those guys have never shown this proving and anything. For the law equations of motion, the teacher has just given equations and he has done some examples. They had never got the chance to do themselves. So imagine if I give you a really big calculation, instantly within like 10 seconds, if I started to explain, they only give the time to them to read it. යාලට read කරගන්න time එක දෙනවා. හදන්න දෙන්නේ පටන් ගත්ත විනාඩි නම් so sir is the guy just doing it because they are just seeing, they think like, oh, I can do it, oh, understood very well, wow. But if they really tried it, only they can understand their real level. But they don't ever take that risk. What do they do is just give the sum, just give the time to them to read, and the sir is the one explaining. ඒ විදිහට කරනවා මම මෙතන ගණන් 1000ක් විතර අද. ඒක තේරුම් නැති වැඩක්. You have to try. Then finally I have to explain. Then only you can understand. But you will understand, oh my god, I can't do it. මට මේක තේරෙන්නේ නැහැ. කියලා උන් දාගෙන ෆිසිකල් ක්ලාස් වලට දුවනවා එතකොට තේරෙයි. එතනදී කියන ඔක්කොම තේරෙනවා. අයි සර්නේ හදන්නේ. යා නෙමෙයි. අයි ටර්ම් ටෙස්ට් එකක් ආවට පස්සේ හොම් බෑන ගන්නවා. ආයි දුවගෙන එනවා. ඕක තමයි කරන්නේ. මම මට ඒක අදාළ නැහැ. මම අම්මා තප්පරේම කරන්නේ මොකද්ද? ඔයාලට හදන්න දෙනවා. බැරි වුණොත් මං හදනවා. තමන් දැනගන්න බෑ තමන්ට බැහැයි කියලා අංගෙක. නේද? ඒ දුන්න જાතිය ගණන් එකක්වත් හදවලා නැහැ. මුන් කොර වෙලා බලන් ඉන්නවා අදලා ගත්තා ඊට පස්සේ සෙට් එක. ඒකයි කියන්නේ මම දැන් පොඩ්ඩකට මේ වලට දෙන weight එක අඩු කරනවා. I reduce the amount of weight because still there are even in this. Oh, you are the second highest marks for physics. I still really upset with you. I'm really upset with you because you are the second highest. You are the second highest. I'm really upset with you. You are a very bad girl. No, 2 marks means still you are the second. 2 marks means still you are the second. You are very bad. Two marks means still you are the second. Right? අම්මේ island first ලව හදන්න try එකක් දෙද්දි මේ ස්කූලෙන් second වෙලා කියනවා I am the second කියලා හරි සන්තෝෂෙන්. ගණන් ගන්න නෑ මම. Very bad. Right. හරි. අපි යමුද අපි ටියුට් එකට ගිහිල්ලා දුක් දාලා exam එකේ ඒක හරියන්න papers practice එකක් දාලා ගණන් ටිකක් හදමුද? ආනේ shall we? Shall we make a move? කියන්නේ. මේ ළමයි කතා කරන්නේ නැහැ. Okay. Is that everybody there? The given time is done for you. So I want to ask you a very important question. First of all, let me know whether everybody is there. හැමෝම ඉන්නවද? ළමයි, everybody there? Is that everybody there? Yeah. I am asking a question now. I need everybody to respond me. I am about to send you the next tube because there are two tubes. I can't send both at the same time. I prepared two prototypes. One is consisting of more theory that you can read and understand. Other version is consist of more questions. What type of theory tube do you need? So if you decide the type, I will send that. So one said like more questions. Okay, everybody, I am just going to go with the majority. If majority asking more questions, I will send you the tube with more questions. If the majority asking with more theory, I will send you the more theory tube. So far I included more theory because you wanted to understand the deep concepts little by little. Now you have almost like adapted to the situation. One said more theory, other one is in the neutral land. Another one said more theory. හැමෝම තමන් කැමති දේ කියන්නටක් ගාලා I want to make finalize. ළමයි, tell me your idea. Another one said more theory. ළමයි, another one said more theory. One said more questions, another one said more theory. හැමෝම vote කරන්න 10 දෙනෙක් ඉන්නවා මෙතන. There are 10 people here. I need everybody's vote. There are 2 people not sending me any answer. දෙන්නෙක් හැංගිලා ඉන්නවා. Then I will have to ask by your name. මට මෙතන නම දාලා නැති කට්ටිය තේනවනේ. One said more questions, one said more theory. So more questions have 3 direct votes, while
6 of these have like more questions. Sorry, more theory. One is no man's land. So I will just create the theory in this way. I was just about to, these two models are like this, 20% theory, 80% questions. That's how question paper was like. So in the other way, normally like 60% of the theory and 40% of questions. එතකොට I will reduce the theory count to 50-50. මම එනම් 50-50 වෙන විදිහට දාන්න. හැමෝටම set වෙන්න. This is what my original design. So I will make a 50-50 stuff. So you will be getting your theory tute very sooner. Yeah, 50-50 දාන්නම් එනං. If you request for question tute, I was just about to prepare it like this. 20% of the theory, only very important parts, and mostly questions. But theory tute, I was just suggested to have it like 80%, 60% of the questions and 40% of, sorry, theory and 40% of questions. Now it's going to be 50-50. Sometimes the theory count will be reduced to like, 45% to other one will be like 55% around like. So this will be the theory tute you will be getting. මොකද මට ඕක මැසේජ් එකක් දාලා අහන්න තිබුණා. ඔයාලගේ මැසේජ් වලට රිප්ලයි කරන විදිය මම දන්නවනේ මේ ලයිව් එකේ හරි අමාරුවෙන් මැසේජ් එකක් ගන්න. සාමාන්‍යයෙන් group එකේ මැසේජ් එකක් දාපුවම ඔයාලා රෙස්පොන්ඩ් කරන්න ගන්නවා දාන්නේ සමහරව. It's really horrible. Okay. Okay, which spring has the greater value of spring constant? Harder spring or delicate? Definitely the harder. Two bodies stick together after collision. What type of collision between two bodies? Right. Stick together. One move. Other one is moving or not moving. But as a result, both will be a same unit and move forward. Right? So what type of collision? Right. So there are two types of collisions I told you. I will have to explain. One is called elastic, other one inelastic, but I didn't teach you so far. That's why I told you, just remind me after interval, I will teach you that concept. It is definitely inelastic type because it is stick together. You don't have any idea what is inelastic yet. So wait for me to teach this part today. I didn't teach you that one yet. Now it is the next part. State the two conditions under which force does no work. If there is no displacement occur. If there is no displacement, like you are trying to just like push a mountain, you apply a force, but there is no work. That's what Navisan asked me, is how to calculate this question. It is almost like 9th question, I think. Yeah, that means perpendicular to the direction of force. Yeah, so apply. If you are just applying parallel to that, nothing would happen. So how much momentum of a body changes if the kinetic energy is doubled? Right. I told you there is a way. That simple equation I gave you, like P is for over 2m. You can use that one even, but for only for the MCQs. But for regularly momentum, half mv square. Right? Here the mass does not change. Imagine what would happen if you double the momentum. sorry, you are doubling the kinetic energy actually. In the next one, 2E is equals to half mv dash square. So you have to find out mv dash. So what you are going to do is dividing equation number 2 by 1. 2 and half m and v, everything going to cancel off. Root 2v. It is going to be root 2v. So when the kinetic energy doubled, the velocity increased by root 2. So the new momentum is going to be what? M root 2v. So what will be the momentum change after kinetic energy doubled? So the momentum is mv. So the momentum is going to change like root 2 times in initial momentum of p. The momentum initially had like p. Now the new momentum is multiplied by root 2 factor. Understand? තේරුණාද නැද්ද? සමහරුන්ට ඔක එකපාරට තේරෙන්නේ නැත්තම් නෑ කියන්න. That's fine. That's better. No means couldn't understand. No means couldn't understand. ළමයි. හරි. ඉමින් සීරුවේ කියලා දෙන්නම්. ලොකු ගානක් නෙමෙයි. Right, I will explain you. Okay. Have a really good look at now. There is a mass. This one is moving with velocity of v, having a kinetic energy of k, ek, and the momentum of p1. Right? Okay. Now you do something to this mass. You double the kinetic energy. So velocity, you don't know. It will definitely have to be v dash. Because if the mass is constant, how to change the kinetic energy? Only by changing the velocity. As velocity change with the constant mass, definitely the momentum has to be changed. Don't you understand? Oh, then at the okay. Right. Now have a good look at ek equals to half mv square, and I will have to write p is equals to mv only. Let me apply it to here. So in next case, 2ek equals to half mv dash square. You changed it. Right. Now I want to find out the new velocity in terms of old velocity. If this is equation number 2 and this is equation number 1, I want to divide it now. Equation number 2 divided by equation number 1. Have a good look at 2ek over ek equals to half mv dash square divided by half mv square. Half m cancel off, ek and ek cancel off. You get like 2 equals to v dash square divided by v square. You get what is v dash square equals to 2 times v square. Your v dash will be what? Root 2 times v. This is like equation x. Now your new momentum, you don't know, p dash is going to be root 2 mv. So you know this one, it is what? P. Your new momentum is in terms of root 2 times earlier momentum. I don't know how to explain furthermore. හැමෝටම තේරෙන්නේ නැති කියලා විශ්වාස කරනවා. හරිද? Hari. Kinetic energy of body is increased by 300%. Find the percentage increase in the momentum. Now the same method, man. It is the same method. Hari. මම හදන්නම්. ඔයාලට ඒක හදාගන්න බැරි වුණා නම් හදන්න ටයිම් එකක් දෙන්නද? Could you do this question? හැමෝම කියන්න තනියෙන් කරගන්න පුළුවන් වුණාද බැරි වුණාද? Could you do this alone or not? I'm asking about the fifth one. හැමෝම ටක් ගාලා drop කරන්න message එකක්. Could it or couldn't? Done. Okay. හැමෝම. Everybody, I need. You said no. Okay. ගොඩක් කට්ටිය නෝ නම් මම chance එකක් දෙනවා. I'm talking about the fifth one. I'm talking about the fifth question. Okay. 3 said no. 4 said no. හැමෝම කියන්න. No. Okay. තව කවුරු හරි ඉන්නවද කරපු නැති? හරි. I think like majority of you couldn't. Now you may try. ඔයාලා try කරන්න. විනාඩි 3ක් විතර දෙන්න. 3 minutes. Okay. Try the fifth one. Hari. Energy is increased by 300%. Asking about increase of momentum. Okay. Taggal try කරද්දී. හොඳ ළමයි වගේ. හරි. මම දුන්න ටයිම් එක ඇති කියලා හිතෙනවා. I think the time I'm given you enough. ආවද උත්තරයක් කරගන්න බැරි වුණා කියපු අය. It says, states the question, kinetic energy of the body increased by 300%. In terms of percentage, if it is 300, in terms of normal, that means it is increased by 3 times. That's it. Well, normal O-level maths එකක්. In the normal O-level, if you increase by something by 2 times, that means the energy increased by what? body increased by 300%. Increased by. හරි නේද? You have like 100% here. The next you increase by 300%. Your new value is what? Nearly 400. Increase 2. Increase 2. No. 300 only නතර වෙනවා. Increase by mean you had 100. You increased it by 300. Now your final value is 400. ඔන්න ඕක හිතා ගන්න ඕනේ. By and 2 කියන දෙකේ වෙනස. That means technically the amount is increased by 4 times. 4 times than initial. Initially you had like half m v square. Leave it. In the next one, 4e equals to half mv dash square. So you can just cancel this thing off and make it a maker. So like that, 4 is equals to v dash square. V dash is equals to only 2 increased by what? 2 times. Your momentum is P is equals to mv in the first case. P dash is going to be 2 mv. So that means P dash is equals to 2p. So if you express that in a percentage wise, your new momentum is what? 200% of P. 200% P. හරි ලේසි ළමයි. වනාරා නියම කෙල්ලෙක්. ඔයාගේ හරි. No. Not root 300. By means different. 2 means increase up to 300%. Up to means 100 to 300. By means you increased additional 300. English is there in physics වලදී. ඔපේසනී. Hello.
Yes, sir.
Now you have a big challenge from your schoolmate. Don't say like that. Don't say like that, නෙමෙයි. I have to ignite a fight between you. මරා ගන්න ඕනේ. Then only you guys get really kind of like what? Motivated to be the first. මම බොරුවට කියන්නේ එහෙම කරන්න එපා. So actually if you are running after like a very big rat race, it will just definitely ruin your life. මම අර සරීනටත් මම වීලුවට වැන්නේ second place එක ගත්තා කියලා. ඇත්තටම second place the first place ද කියන එක නෙමෙයි. How to win your life. So your race should be actually with you. හරිද? ඇත්ත කතන්දරේ ඔයාලගේ race එක තියෙන්නේ කාත් එක්කද? With yourself. ඔයා දුවන්න ඕනේ ඔයත් එක්ක. You have to make always a better you. ඊයේ හිටපු ඔයාට වඩා අද ඉන්න ඔයා පට්ට පොරක් වෙන්න ඕනේ. එතකොට your timing, your capacity, your look, everything you have to improve. හැමදේම. තේරුණාද? So the only person you have to compare with you is who? In the world, you have to only compare you with only one person. You can turn back and see who your comparison. It is you in yesterday and this is you in today. ඔයාගේ ගේම් එකකත් එක්ක තියෙනවා iPhone. ලෝකෙත් එක්ක නෙමෙයි. If you fight with yourself, if you overcome your fear, if you overcome your laziness, if you overcome your bad habits, then you will be better of you. In the next day also you turn back and see what is your things and right. හැමතිස්සෙම නිකන් අර side rear view mirror එකකින් වගේ බල බල යන්න ඕනේ. හැබැයි but in the rear view mirror in your vehicle whenever you ride you have a kind of rear view mirror, but you keep focusing on the forward direction and sometimes backward, but you just very barely timely you spared this one for few fractions of second and watch your path and move forward. හැමතිස්සෙම අතීතයේ හිටපු කෙනා දිහා බල බල ඉන්නත් හොඳ නැහැ. You should not watch who you were all the time. It is like a rear view mirror. ටග්ගා තප්පර දශම ගානක් ඇතුළත බැලුවා ඉස්සරහට ගියා. පහු කරන් ආපු දේවල්. But you will have to keep focusing more of your forward path. තේරුණා නේද? එතකොට දැන් මම සරීනට විලුවට වැන්නා. සරීනා you got second place. ඒ මම ඇත්තටම විලුවට කිව්වේ. හරිද? But your second place is I really appreciate. But second place, you got second place by only 2 marks, no? Isn't that Sarina? For me, Sarina?
Yes, sir.
Yeah, you got it reduced by 2 marks. Is that because of the other boy or girl? Is that a boy or girl?
It's a girl.
Who is her name? What is her
Miriam.
name? Huh?
What the first place?
What is her name, man?
Name of the first place?
Yeah.
Miriam.
Miriam. අමුතු නමක් ඒක. හරි. දැන් ඔය මීරියම් කියන girl first උනා කියමුකෝ. ඒතර ඔයාගේද ඔයාට ඇත්තටම මීරියම්ද challenge එකක් වුණේ මොනවාද? Was that you became your own challenge or Miriam became? Your bad habits. පාර ටික දවසක් ඉන්නේ සති දෙක තුනක් විතර වගේ පිස්සු කියලා. That's why you hadn't had enough time to study. If you studied in those 3 to 4 weeks, so you could beat her by like 5 to 6 marks. Then you are the first. තේරුණාද? ඉතින් හැමතිස්සෙම always try to make a better version of you than the yesterday. හැමදාම මේක ඔළුවේ හිතේ තියාගන්න. ඊයේ හිටියේ ඔයාට වඩා හෙට ඉන්නවා හොඳ කෙනෙක් වෙනවමයි කියලා. එතකොට your challenge will be you, not anybody else. තේරුණානේ? එතකොට මගේ ලයිෆ් එකේ මට කිසිම challenge එකක් නැහැ තව එකකින්. Right? If I am just behind him or her, that means it is my mistake, not his strength. Rather than his strength, it's my own weakness. So I have to fight with my own weakness. තමයි මම හැමතිස්සෙම හිතන්නේ. හරිනේ? කියන්න. හොඳයි. The next one, a light and heavy body have same kinetic energy. Which of the have more momentum. Okay, same kinetic energy. I will give you a good example. Ek is equals to half mv square. Okay, that means you can get it like 1 kilogram object multiplied by 4 to the power 2. Your answer will be what? 16.8. You are going to get the same 8 joule in using a smaller mass. Sorry, larger mass. 8 joule by 2 kg. What is the velocity is going to be? Right? For velocity is going to be what? 2 ms minus 1. Right. Mass එක මොකද වුනේ? Same joule count you are going to get with 2 ms minus 1. In the first case, what is your momentum? Have a good look at in the momentum. Momentum equals to mv. M is 1, v by 4. Your answer is 4 kg ms minus 1. Here, what is mass? 2 kg, isn't that? What is momentum? 2 times 2, 4. Isn't that? Right. Let's get another example. Oh, wait. මම මෙතන පොඩි අවුලක් කරා. I forgot to put half here. Two root 2 ms minus 1. So the momentum factor here is going to be root 2 times 2 ms minus 1. Sorry, kg ms minus 1. 4 root 2 kg ms minus 1. Here you get like only 2, 4. Here you get like what? Bigger momentum. That means if the velocity factor increases but the mass, remember always kinetic energy to velocity factor is square factor. So if the velocity is always getting as a factor of kinetic energy, you can get higher kinetic energy but the velocity increased by a root factor. Understand? Root එකකින් තමයි වැඩි වෙන්නේ. So, but here it affected by directly the velocity. If you double the kinetic energy by velocity, changing the velocity, you have to change the velocity by only a root 2 factor. But the mass, if you are changing it by mass, it directly affects. Understand? Momentum change by moment. So here, if it is only changing by increasing velocity, but the momentum is changing by a very small factor. So heavy mass with low velocity has higher momentum than low mass with higher velocity. In terms of comparing with the kinetic energy. මේක හොඳට මේ ගාන දෙපාරක් විතර හදලා බලන්න එතකොට තේරෙයි හරියට. sorry. Does the potential energy of a spring decreases or spring when it is compressed or stretched? So the potential energy of a spring decrease or increase when it is compressed or stretched? Increase. කෙලින්ම වැඩි වෙනවා. Name a process with the momentum changes but kinetic energy does not change. Why? So the kinetic energy means what? Change of mass and change of velocity. If it is like reducing weight while increasing velocity, so there will be a definite change of momentum, but the kinetic energy will be remaining as same as I mentioned in the above. So you have to know like increasing velocity by root 2 and decreasing mass by 2. So your result of the momentum will change, but the kinetic energy does not. Because why? M reduced M over 2 multiplied by root 2 times V to the power 2. So what's happening? M over 2 and V over V by 2, V square by 2 comes. So factor cancel off. You have to mention like a situation where mass reduced by 2 while velocity increased by root 2. Name a process which the momentum changes. I told you, a body of moving at constant speed over a frictionless surface. What is the work done by the weight of the body? It is a frictionless surface, then 0. If it has a friction, it is a different case. Why? Work done equals to mu mg into d. But here the mu factor is 0. That means no work is done. Define in spring constant. I told you the force required to change the unit length of a spring. Right. Let's check the timer. We have like 15 minutes for doing. Right. Until then, I will teach you the next theory. Write the next theory. Power. Did we learn the power theory in the last week? I hope no. Did we? No. Okay. Now write the subtopic power. Unit is W or Js minus 1. Joules per second or watt. Okay. Now write the definition. The rate of change of work done. Number 1 is the rate of change of work done. There is another definition. The other definition is work done per unit time. Work done per unit time. Let's write the equation in words. Power equals to work done over time taken. W over T. Copy this. I hope you done copying that. You done copying that. So let's get the unit analysis. In here, the work done is in joules. This one is in seconds. So that is why the unit is JS minus 1. Or in other case, what is it? kg m squared s minus 3 in terms of the units. So for these two, we can represent in terms of abbreviated unit. That is it what? Omega, sorry, not omega, watt. James Watt. Right. I hope you understand this. Now the next step is let's write a very simple example question. A body of mass 2.5 ton in simple T is raised to a height of 90 meter under a time of 2 minutes. Find out the power of crane used in you lift it to certain 90 meters. T equals 0. It took some time of T here. T equals 2 minutes actually under gravity. So try to find it. What is the power? That's the question. Okay, right. හරි හැදුවද? ඇති දුන්න ටයිම් එක. Tell me your answers quickly. තමයි සරීනා විතරයි මට උත්තරයක් දැම්මේ. අනිත් අය operation is sent me an answer. Okay. හරි. අපි හදමු. මම හදන්න. We know that power equals to work done over time. In terms of the work done, it is the work done against gravity mg into h over time. Very simple. So mass is like 2.5 ton. 2.5 by 1000. You have to remember your units and dimension thingy. I told you there are some SI unit kind of like what derivatives. These are like in for higher masses we use tons. So it is like 2.5 into 1000 and times 10, and the height is of light 90. It has taken some 2 minutes. 2 into 60. 3 and 2. Okay, now it is going to be 2.25 and 1000 from here by 3 over 4. That is more like I can get this 4 vanished by 250 by 100. I can separate this as 100 here by 3 over 4. So once I cancel off, it becomes 25. 25 times 25 is going to be 625, and 0 is there, and you have to multiply this by 3. 600 times 600 is 3 is like 1800. 25 times 3 is like 1875, and this 0 18,750 watt. Very good. So in terms of kilowatt, we can get it like 18.75 kilowatt. I think that Sarina's answer is very correct. The answer is correct. Hmm. හරිද ළමයි? ඔක තේරෙන්නේ නැති කියලා හිතනවා. අපි විනාඩි 10ක ඉන්ටර්වල් එකක් අරන් යමුද? Are we having 10-minute interval and do more questions and including explanation of the elastic and inelastic collisions? හරි නේද? Shall we? Okay, I'm going to give you interval. Your interval starts now.